Hi everyone. In this video we are going to go through the solutions to quiz number 2. The first problem, we were given a matrix and a vector. You have to write an augmented matrix for which linear system corresponds to the matrix equation Ax equals b, and then solve the system, write the solution as a vector. And as in most cases, 80% of the time, we're going to augment and write and perform some row operations. 5, 2, minus 2, minus 5, 1, 3. We'll do a dotted line. I might not do that with every step though. Negative 4, 2, 37 as my vector b. All right, and so we do our row operations. We use our leading one, that's this guy, and we want to eliminate the two entries that are below it. So we'll rewrite row 1, 1, 5, minus 5, minus 4. And then negate and add to eliminate that entry, make it a 0, negate the 1, add the 1, negate 5 and add 2, I get negative 3. Negate the negative 5, I get positive 5, add 1, I get 6. Negate negative 4, I get positive 4, add 2, I get 6 again. And then we have opposite signs for the bottom one, so we're going to multiply by 4 and add. That's going to give us a 0 here. 5 times 4 is 20, add negative 2. Negative 5 times 4 is negative 20, add 3 is negative 17, and then 4 times negative 4 is negative 16, add the 37, and I believe you get 21 as our first step to solving this guy. All right, continuing our row operations, we'll keep row 1 the same, 1, 5, minus 4. And notice here we have a factor of negative 1/3. So we can take that out. Oops, make that a negative 2. There we go. So I'm multiplying row 2 by negative 1/3. And then row 3, we're going to use this leading entry of negative 3 to eliminate the 18 that's below it. So we're going to multiply by 6 and then add. All right, that's going to give me a 0 here, a 0 here. 6 times 6 is 36. Minus 17 is 19. And then 6 times 6 again is 36. Add 21, and you get 57, which is ugly, but it happens to be divisible by, oddly enough, 19. All right, so let's do one more step on this row, where we get our last leading 1. So I have a 1, 0, 0, a 5, 1, 0, a negative 5, negative 2, and if I take 19 out of row 3, divide it by 19, I get a 3 as that last entry. Okay, and now I'm in echelon form. I want to get into reduced echelon form. So we're going to go back up the stairs. Let me change colors here. We're going to use this one to eliminate the two entries that are above it first. Okay, so let me rewrite what's not going to change. 5, 1, 0. All right, so we're going to double and add the middle row. That's going to give me a 0 here. If I double the 1, add negative 2, right? And then if I double the 3, that's 6. Add negative 2, I get 4. Bottom row is not changing. Okay, so now we have two solutions to our system, to our matrix equation Ax equals b. Finally, use the 1 to eliminate the negative 5 above it, so I multiply by 5 and add to get this 0. 5 times 1 minus 5. And then 5 times 3 is 15, minus 4 is 11. One more step. 0, 0, 1, 3 at the bottom does not change. 0, 1, 0, 4 in the middle does not change. But now I'm going to use my next one going up the stairs to eliminate the 5 that's above it. This 1 doesn't change. And I eliminate the 5 by multiplying by negative 5 and then adding. I get 0 here. That 0 doesn't change. 4 times negative 5 is negative 20. Add 11 is negative 9. All right, so there's all of our row operations. There's a bunch of them. The problem does say to write the solution as a vector. So we're going to go x equals. My solution vector is negative 9, 4, and 3 is the bottom entry. All right, now moving on to problem number 2. We have a homogeneous system, and it says to write the solution in parametric vector form. So the first step, augment with a column of zeros and do some row operations. 3, 4, negative 7, minus 5, minus 8, 9, and then my column of zeros because we are homogeneous. All right, I'll do the first two row operations. Row 1 doesn't change. Row 2, if I negate and add, I get 0, 1, minus 3, 0. And then row 3, if I multiply by 3 and add, I get 0, 2, minus 6, 0. Go through those computations by hand, right? We negated in row 1, added row 2, and then tripled row 1, added row 3. Let me write that down, just since I didn't go through that one specifically. Negate row 1, add row 2, put it in row 2. Ooh, that's a 3. 3 row 1, add row 2, put it in row 2. Oh, excuse me, that one was row 3. There we go. All right, so there's our first step. Next up, we have a leading 1, and if you use it to eliminate the entry that is below it, I believe we're going to get a row of zeros. 0, 1, minus 3, 0. Yeah, because rows 2 and 3 do just scale each other, so we get a row of zeros there. Before I go to my solution, though, it is incorrect to go to the solution yet. I need to first go back up the stairs, right? So I have a pivot with zeros below it. I have a pivot with 0 below it, but I also need to go and put a 0 above it, and I don't have a third pivot to worry about. Okay, so we do have one more row operation. Okay, my middle row, 0, 1, negative 3, 0. My bottom row, a bunch of zeros. Those don't change, but the top row will. So if I use this 1 here to eliminate the 3 that's above it, I need to multiply it by negative 3. Negative 3 times 0, add 1, I get 1. Negative 3 times 1 is negative 3. Add 3, I get 0. Negative 3 times negative 3 is positive 9. Add the negative 5, I believe I'm going to get 4, yes. And then 0 doesn't change. Okay, so there's the work in my matrix. The solution in parametric vector form, we go x equals. My three variables here are x1, x2, and x3. And the free variable, the missing pivot, is right here in x3. So x3 stays x3. It's free to be whatever it wants to be. And I write x2 in terms of x3. That would be 3x3 because the negative 3 here would add to the other side if we're solving for x2. And x1 would be, where was I? Negative 4. There we go. x3. Because I really should have circled this negative 3. That negative 3 would add to the other side, and this 4x3 we would subtract onto the other side. Okay? And then the only other thing I want to do here is factor that scalar out of each entry, and we have x3 times negative 4, 3, and 1. So there's our solution in parametric vector form. The other thing that the question asks is to provide a geometric interpretation of that solution, and what I'm looking for there is something along the lines of this. It looks like a line through the origin, I can spell, the origin in the direction of our vector, so of negative 4, 3, 1. Any point on that line satisfies the homogeneous system that is given in this question. Okay, and last we have problem number 3. We have a flow of traffic in vehicles per hour through a network of streets, and I'm going to label each of these intersections 1, 2, 3, and 4, and write down an equation modeling each of those intersections. Okay, so at intersection 1, what's going into that intersection? We have 400. And x2 going in. What's coming out? The only thing coming out is x1. So there's our first equation. At intersection 2, what's going in? We have x1 plus x3 going in, and coming out of intersection 2 is 600 plus x4. Then at intersection 3, let's see, what do we have going into that intersection? The only thing going in is 300 cars an hour. And what's coming out? Well, x2 is coming out, x3 is coming out, and x5 is coming out of that intersection. And then the last one, at intersection 4, we have x4 and x5 going in, and 100 cars an hour coming out. Okay, so there's our system just pulled from the picture. I could take and rewrite each of, and I think I will rewrite each of these just to look a little bit better for when I write my augmented matrix. So that's going to look like this. For the first equation, I want to write it as x1 minus x2, then I'll leave some space there, equals 400. So I'm just subtracting the x2 and flipping over the equal sign. For the second equation, I have x1 plus x3 minus x4 equals 600. And then the third equation, I'm just going to flip over the equal sign. X2 plus x3 plus x5 equals 300. Bottom equation can stay the same. X4 plus x5 equals 100. Okay, and that's just going to help me to write my augmented matrix a little bit more easily. Now that's going to have 6 columns, so I need to make sure that on the left every row has 5 entries before the equal sign. So the top row, I have a 1 and a -1, and then 1, 2, 3 zeros, and then my 400. And then for the second row, there's a 1, there's no x2s, there's an x3, there's a minus x4, there's no x5s, and that one's got 600. For the third row, there's no x1s, there's an x2, there's an x3, and an x5, 300. And then the bottom row, all we have in that row is an x4 and an x5 equals 100. Okay, that's a dash, part of a dash. There we go. All right, so there's our augmented matrix. You could do row operations, but this one specifically said, save some time, use the TI-89. If I key that in, RREF in the 89, we get this, that looks terrible. We get this guy spit out. Let's see, X1 with zeros below it. And x2 column looks like this, 0, 1, 0, 0. And my x3 column is 1, 1, 0, 0. x4, 0, 0, 1, 0. x5 has a 1, a 1, a 1, and a 0. Dotted line, 700, 300, 100, and 0. All right, and so what we find, we get a row of zeros. We also, hopefully you notice that there is a missing pivot in column number 3, and there is a missing pivot in column number 5. If you didn't notice that, well, circle your pivots. There's one, and there's one. Only those 3 pivots. The 2 arrowed columns have missing pivots. So I'm just going to make a note here. X3 is free, and x5 is free. All right. Now, the last, and that was all that part A wanted you to do, was to solve the system. You could write it in terms of x1, you could write it out as a solution. I'm just going to leave it in my matrix for this step, but if you took one more step and went a little bit further, then, well, hey, that's even better. For part B, it's saying let x3 equals 0 and x5 is 100. Well, if you're given those 2 pieces of information, then you can say that x1 is 600, x2 is 200, and x4 is 0. Go back and check. That's the only possible scenario there. And then for C, if x3 is 100 and x5 is also 100, then x1 has to be 500, x2 has to be 100, and x4 is 0. Okay, so given those 2 different setups, that's what the rest of the system looks like. Okay, so there are the solutions to your quiz. If anything was unclear, if you have any further questions, please let me know, send me an email, or come see me. Thank you for watching.